CSC 208. Computer Networks and Data Communication. This course covers the fundamentals of data communications and networking. Data communications refer to the transmission of this digital data between two or more computers, and a computer network, or data network, is a telecommunications network that allows computers to exchange data. You will be introduced to the fundamentals of data communications, as well as the techniques, applications, and management of modern data communications networks. You will gain a comprehensive understanding of data communications and computer networking systems. This course will also introduce you to the evolutionary trend of computer networks. It will help you in understanding the procedure of transmitting data over the network and how to resolve the conflicting issues arising in the course of transmission. Study Session 1. Computer Networks. Introduction. You will discover in this study session that a computer network is a collection of computers linked together by wires, optical fibers, or optical links so that diverse devices can communicate with one another through a network. The purpose of a computer network is to allow different devices to share resources. What is computer network? A computer network is also a group of computers linked to each other that enables the computer to communicate with another computer and share their resources, data, and applications. A computer network is a collection of interconnected computers and electronic devices such as printers. This connectivity allows computers to share information more easily. Computers can communicate with one another via wired or wireless media. Classification of computer networks. Computer networks are classified based on various factors. They include geographical span, interconnectivity, administration, architecture, network applications. A network is formed by connecting computer systems and peripherals. They have several advantages. Resource sharing such as printers and storage devices. Exchange of information using emails and FTP. Information sharing by using the web or internet. Interaction with other users using dynamic web pages. IP phones. Video conferences. Parallel computing. Instant messaging. Types of computer network. In general, networks are classified according to their geographic scope. A network can be as little as the distance between your phone and its Bluetooth headphones, or as wide as the Internet, which spans the entire globe. 1. PAN, Personal Area Network. Thomas Zimmerman was the first research scientist to bring the idea of the personal area network. Personal computer devices that are used to develop the personal area network are the laptop, mobile phones, media players, and PlayStations. PAN is a network that is set up within a single person and normally has a range of 10 meters. PAN may include wireless computer keyboards and mouse, Bluetooth-enabled headphones, wireless printers, and TV remotes. 2. LAN, Local Area Network. LAN is used for connecting two or more personal computers through a communication medium such as a twisted pair, coaxial cable, etc. It is less costly as it is built with inexpensive hardware such as hubs, network adapters, and Ethernet cables. The data is transferred at an extremely faster rate in the local area network. LAN also provides higher security. 3. MAN, Metropolitan Area Network. A metropolitan area network, MAN, is a network that connects multiple LANs to form a larger network that covers a greater geographic area. Its range is greater than that of a local area network, LAN, and is also used by government organizations to engage with citizens and private businesses. MAN connects many LANs using a telephone exchange line. RS-232, Frame Relay, ATM, ISDN, OC3, ADSL, and other protocols are commonly used in MAN. Uses of Metropolitan Area Network. The MAN protocol is used to communicate across banks in a city. It can be used in a college within a city. It can also be used for communication in the military. It can be used to book an airline ticket. 4. WAN, Wide Area Network. Wide Area Network, WAN, is a network that spans a vast geographic area, such as many states or countries. It is also bigger than LAN, and it's widely used in the field of government, business, and education. A wide area network, WAN, is a network that connects multiple locations over a vast geographical area via a telephone line, fiber optic cable, or satellite connectivity. Examples of WAN are mobile broadband, last mile, and private network. 5. Internetwork. An internetwork, or simply the Internet, is a network of networks. It is the world's largest network of any kind. All WANs are extensively connected by the Internet, which can also link to LANs and home networks. TCP/IP is the Internet's protocol suite, while IP is its addressing protocol. In today's world, IP4 is widely used on the Internet. It is gradually moving from IP4 to IP6 due to a scarcity of address spaces. Network LAN technologies. Let's take a quick look at the various LAN technologies. Ethernet. Ethernet is one of the most extensively used LAN technologies. Ethernet is a media sharing protocol. Data collision is very likely in a network that employs shared media. To detect collisions, Ethernet employs carrier-sense multi-access/collision detection (CSMA/CD) technology. When an Ethernet host encounters a collision, all of the hosts roll back, wait for a random amount of time, and then retransmit the data. Fast Ethernet. Ethernet is extended as Fast Ethernet to address the requirement for fast-growing software and hardware advancements. It works with UTP, optical fiber, and wireless connections. It has a speed of up to 100 megabytes per second. For wired media sharing among Ethernet hosts, it uses the CSMA/CD approach, while for wireless Ethernet LAN, it uses the CSMA/CA. CA stands for Collision Avoidance Technique. Giga Ethernet. Fast Ethernet was released in 1995 and only kept its high-speed status for 3 years before Giga Ethernet was developed. Giga Ethernet offers speeds of up to 1000 megabits per second. Virtual LAN. Ethernet is used in a LAN, and shared media is used. Ethernet creates a single broadcast domain and a single collision domain when shared media is used. Switches have solved the problem of a single collision domain, and each device connected to a switch now has its collision domain. Switches, on the other hand, are unable to separate a network into distinct broadcast domains. Summary of Study Session 1. In Study Session 1, please note the following. 1. Ethernet is one of the most extensively used LAN technologies. 2. Email, instant messaging, blogging, social media, marketing are some purposes of the Internet. 3. A computer network is a collection of interconnected computers and electronic devices such as printers. 4. Geographical span, interconnectivity, administration, and architecture are classification of computer network. Study Session 2. Computer Network Topologies, Model, and Security. Introduction. The term topology refers to the connection between endpoints or stations connected to a network connection, as well as the system configuration of a computer. This topology can be physical or intellectual. The physical connection, also known as topology, refers to the actual layout of a network, which includes all devices, their installation, and their location. The data transmission in a network built for is referred to as logical topology. In network cabling, particularly CCTV installations, the network topology is critical. Network topology. The arrangement in which computer systems or network devices are connected is referred to as a network topology. Both the physical and conceptual aspects of a network can be defined by topologies. In the same network, the logical and physical topologies could be the same or distinct. The network topology can be categorized into various types such as point-to-point, ring, bus, mesh, star, and tree topology. Point-to-point. A point-to-point network is made up of exactly two hosts, such as computers, switches, routers, or servers, that are connected back-to-back using a single piece of cable. Frequently, one host's receiving end is connected to the sending end of the other, and vice versa. If the hosts are connected point-to-point logically, they may have multiple intermediate devices. Bus topology. Bus topology is the common backbone of the entire topology. It is characterized by the utilization of multiple points medium. In the bus topology, the computers and the devices are connected to an appropriate tap-like structure, and the devices are called a tap. The full duplex data transmission allows the computer to send data and receive the data through the bus. All devices in a bus topology share a single communication line or cable. When numerous hosts are sending data at the same time, the bus topology may cause problems. To solve the problem, bus topology either employs CSMA/CD technology or recognizes one host as bus master. It is a simple form of networking in which the failure of one device has no impact on the other devices. However, if the shared communication channel fails, all other devices will stop working. Star topology. In a star topology, A central connection point called a hub is directly connected to each station through a common node. The star topology prevents traffic from reaching the connected devices directly. In the star topology, the controller serves as a mediator. The controller receives data from the device that wishes to deliver it to another device. The data is relayed to the linked device by the controller. A point-to-point connection connects all hosts in a star architecture to a central device, known as the hub device. Ring topology. Each host machine in a ring topology links to exactly two other machines, forming a circular network structure. When a host tries to communicate with or send a message to a host that isn't directly adjacent to it, the data is routed through all intermediary hosts. The administrator may simply require one additional cable to join one more host in the existing structure. Mesh topology. The routes concept was introduced through mesh topology. Unlike ring topology, the data can be transmitted and received from multiple sources to destinations. In a mesh topology, every device has its dedicated point-to-point link. This dedicated word implies carrying traffic between the two devices. Hosts in mesh topology also work as relays for other hosts which do not have direct point-to-point links. Mesh technology comes into two types. Small black square, full mesh. All hosts have a point-to-point connection to every other host in the network. It provides the most reliable network structure among all network topologies. Small black square, partially mesh. Not all hosts have a point-to-point connection to every other host. Hosts connect in some arbitrary fashion. This topology exists where we need to provide reliability to some hosts out of all. Tree topology. A tree topology is the generalization of the bus topology. Several star topologies are connected to a bus. The transmission medium is a branching cable with zero closed loops. The tree topology begins with a connection from the head. The branches are the various star topologies connected through the hub. Each hub acts as the root of the topology. The transmission of the data propagates through a medium and the data can be received at all other stations. The network is divided into numerous levels/layers using this topology. A network is divided into three categories of network devices, mostly inlands. Daisy chain. This topology creates a linear connection between all of the hosts. Except for the end hosts, all hosts are connected to only two hosts, similar to a ring topology. If the end hosts of a daisy chain are connected, the topology is referred to as ring topology. A single point of failure is represented by each link in a daisy chain topology. Every broken link divides the network into two halves. Every intermediate host acts as a relay for the hosts in its immediate vicinity. Hybrid topology. Hybrid topology refers to a network structure with many topologies in its design. The advantages and disadvantages of each incorporating topology are passed down to the hybrid topology. The image above illustrates a topology that has been randomly hybridized. Aspects of star, ring, bus, and daisy chain topologies may be present in the merging topologies. The majority of ones are connected using a dual ring topology, and the networks that connect to them are typically star topologies. The Internet is the most well-known example of a hybrid topology. Computer network model. Software, firmware, chip-level engineering, hardware, and electric pulses all play a role in network engineering. The entire networking concept is separated into numerous layers to make network engineering easier. Each layer is responsible for a certain task and is independent of the others. However, practically all networking operations rely on all of these layers in some way. Layers share data and rely on each other only to accept and send input and output. 1. Layered tasks. One entire network process is separated into small jobs in the layered architecture of the network model. Each little task is subsequently allocated to a layer that is solely responsible for completing the assignment. Each layer is responsible for only one type of task. 2. OSI model. For all communication systems, Open System Interconnect is an open standard. The International Standard Organization, ISO, created the OSI model, ISO. There are 7 levels in this model. Application layer. This layer is responsible for providing an interface to the application user. This layer encompasses protocols that directly interact with the user. Presentation layer. This layer defines how data in the native format of the remote host should be presented in the native format of the host. Session layer. This layer maintains sessions between remote hosts. For example, once user/password authentication is done, the remote host maintains this session for a while and does not ask for authentication again in that period. Transport layer. This layer is responsible for end-to-end delivery between hosts. Network layer. This layer is responsible for addressing assignments and uniquely addressing hosts in a network. Data link layer. This layer is responsible for reading and writing data from and onto the line. Link errors are detected at this layer. Physical layer. This layer defines the hardware, cabling, wiring, power output, pulse rate, etc. 3. Internet model. TCP/IP protocol suite, often known as Internet Suite, is used on the Internet. This is the definition of the Internet model, which has a 4-layer design. The OC model is a broad communication paradigm, whereas the Internet model is the model used by the Internet for all communication. The Internet, like its underlying network architecture, is self-contained. This model has the following layers. Application layer. This layer defines the protocol which enables users to interact with the network. For example, FTP, HTTP, etc. Transport layer. This layer defines how data should flow between hosts. The major protocol at this layer is Transmission Control Protocol, TCP. This layer ensures data delivered between hosts is in order and is responsible for end-to-end delivery. Small black square, Internet layer, Internet Protocol, IP, works on this layer. This layer facilitates host addressing and recognition. This layer defines routing. Small black square, link layer. This layer provides a mechanism for sending and receiving actual data. Unlike its OC model counterpart, this layer is independent of underlying network architecture and hardware. Computer network security. During the early days of the Internet, it was primarily used by the military and universities for research and development. Data was used to pass through the public transit network before all networks converged and formed the Internet. Data that is highly sensitive, such as bank credentials, usernames, and passwords, personal documents, online shopping information, or confidential documents, may be sent by ordinary individuals. All security threats are intentional. They occur only if intentionally triggered. Security threats can be divided into the following categories. Interruption. Interruption is a security threat in which the availability of resources is attacked. For example, a user is unable to access its web server or the web server is hijacked. Privacy breach. In this threat, the privacy of a user is compromised. Someone, who is not the authorized person, is accessing or intercepting data sent or received by the originally authenticated user. Integrity. This type of threat includes any alteration or modification in the original context of communication. The attacker intercepts and receives the data sent by the sender, and the attacker then either modifies or generates false data and sends it to the receiver. The receiver receives the data assuming that it is being sent by the original sender. Authenticity. This threat occurs when an attacker or a security violator poses as a genuine person and accesses the resources or communicates with other genuine users. Cryptography is a technique to encrypt plain text data which makes it difficult to understand and interpret. There are several cryptographic algorithms available present day as described below. Secret key. Public key. Message digest. Secret key encryption. One secret key is shared by both the sender and the receiver. At the sender's end, this secret key is used to encrypt the data. After the data has been encrypted, it is transferred to the recipient over the public Internet. The encrypted data packets can be easily deciphered because the receiver knows and holds the secret key. Data encryption standard is an example of secret key encryption, DES. Secret key encryption necessitates having a separate key for each network host, making it difficult to administer. Public key encryption. In this encryption system, every user gets a secret key and it is not in the shared domain. The secret key is never revealed in the public domain. Along with the secret key, every user has a public key. The public key is always made public and is used by senders to encrypt the data. When the user receives the encrypted data, he can easily decrypt it by using its own secret key. An example of public key encryption is Rivest Shamir Adelman, RSA. Summary of Study Session 2. In Study Session 2, please note the following. 1. The arrangement in which computer systems or network devices are connected is referred to as a network topology. 2. A point-to-point network is made up of exactly two hosts, such as computers, switches, routers, or servers, that are connected back-to-back using a single piece of cable. 3. The OC model is a broad communication paradigm, whereas the Internet model is the model used by the Internet for all communication. The Internet, like its underlying network architecture, is self-contained. 4. Data encryption standard is an example of secret key encryption, DES. Secret key encryption necessitates having a separate key for each network host, making it difficult to administer. 5. Cryptography is a technique to encrypt. Study Session 3. Physical Layer Introduction, Digital and Analog Transmission. Introduction. The physical layer of the OC network model is the only one that deals with the physical connection between two separate stations. This layer specifies the hardware, cabling, wiring, frequencies, and pulses that are utilized to represent binary signals, among other things. Data link layer receives services from the physical layer. What is physical layer introduction? The physical layer of the OC network model is the only one that deals with the physical connection between two separate stations. This layer specifies the hardware, cabling, wiring, frequencies, and pulses that are utilized to represent binary signals, among other things. Data link layer receives services from the physical layer. Data link layer receives services from the physical layer. The physical layer receives frames from the data link layer. They are converted to electrical pulses, which represent binary data, by the physical layer. After that, the binary data is transferred across wired or wireless mediums. Signals. Data must first be transformed into electromagnetic signals before being delivered via physical media. Data might be analogs, such as human speech, or digital, such as a disk file. Digital and analog signals can be used to represent both analog and digital data. Digital signals. Digital signals are discrete and represent a sequence of voltage pulses. Digital signals are used within the circuitry of a computer system. Analog signals. Analog signals are in the continuous waveforms in nature and are represented by continuous electromagnetic waves. Transmission impairment. When signals travel through the medium, they tend to deteriorate. This may have many reasons as given. Attenuation. The signal must be powerful enough for the receiver to accurately comprehend the data. When a signal travels through a medium, it becomes weaker. Dispersion. Signals tend to spread and overlap as they travel through the media. The amount of dispersion is determined by the frequency. Delay distortion. Signals are conveyed at a predetermined pace and frequency across the media. If the transmission speed and frequency do not match, the signal may arrive at its destination unpredictably. It is crucial in digital media that some bits arrive before those that have already been delivered. Noise. Random disturbance or fluctuation in an analog or digital signal is said to be noise in the signal, which may distort the actual information being carried. Noise can be characterized in one of the following classes. Thermal noise. Heat agitates a medium's electronic conductors, perhaps introducing noise. Thermal noise is unavoidable up to a certain point. Intermodulation. When various frequencies use the same medium, interference can result in noise. When two different frequencies share a medium and one of them has excessive strength or the component itself isn't working properly, intermodulation noise arises, and the resultant frequency may not be transmitted as planned. Crosstalk. When a foreign signal enters the media, this type of noise occurs. This is because the signal in one medium influences the signal in the other. Impulse. Unusual disturbances, such as lightning, electricity, short circuits, or malfunctioning components, generate this noise. This type of noise primarily affects digital data. Transmission media. Transmission media refers to the medium used to send data between two computer systems. There are two types of transmission media. Guided media. All communication wires/cables, such as UTP, coaxial cables, and fiber optics, are guided media. The sender and receiver are directly connected in this media, and information is sent, directed, through it. Unguided media. Because there is no connection between the transmitter and receiver, wireless or open-air space is considered unguided media. Information is disseminated across the air, and anyone, including the intended recipient, can acquire it. Channel capacity. The channel capacity refers to the rate at which data is transmitted. In the digital realm, we refer to it as data rate. It is determined by several factors, including bandwidth, the physical limitation of underlying media. Error rate, incorrect reception of information because of noise. Encoding, the number of levels used for signaling. Multiplexing. Multiplexing is a method of combining and transmitting numerous data streams over a single channel. This technique necessitates system hardware such as a multiplexer for multiplexing streams and sending them through a medium, as well as a demultiplexer for extracting data from the medium and distributing it to various destinations. Switching. Data/information is transmitted from a source to a destination that is not directly connected via a switching mechanism. Interconnecting devices are components of networks that take data from directly connected sources, store it, evaluate it, and then transfer it to the next interconnecting device closest to the destination. Switching can be categorized as line coding. Line coding is the process of transforming digital data into digital signals. Binary data is the most common type of digital data. Internally, it is represented, stored, as a succession of ones and zeros. A discrete signal, which represents digital data, denotes a digital signal. There are three different types of line coding schemes. They are unipolar, polar, and bipolar. Block coding. Redundant bits are utilized to assure the accuracy of the received data frame. In even parity, for example, one parity bit is inserted to make the frame's count of ones even. The original number of bits is raised in this way. It's known as block coding. Block coding involves three steps. 1. Division. 2. Substitution. 3. Combination. After block coding is done, it is line coded for transmission. Analog to digital conversion. Microphones produce analog voice, while cameras provide analog video, both of which are processed as analog data. Analog to digital conversion is required to transport this analog data via digital impulses. Digital data is discrete, but analog data is a continuous stream of data in the waveform. Pulse code modulation is used to convert analog waves into digital data, PCM. PCM is one of the most commonly used methods to convert analog data into digital form. It involves three steps. Sampling. The rate at which an analog signal is sampled is the most essential factor in sampling. The sample rate must be at least 2 times the signal's maximum frequency. Quantization. Sampling transforms a continuous analog signal into a discrete form. Every discrete pattern depicts the analog signal's amplitude at that particular time. The quantization is carried out between the maximum and least amplitude values. Encoding. Each approximated value is then transformed into binary format during encoding. Transmission modes. How data is sent between two computers is determined by the transmission method. Binary data in the form of ones and zeros can be transmitted in two ways: parallel and serial. Parallel transmission. The binary bits are grouped into fixed-length groups. With the same number of data lines, the transmitter and receiver are connected in parallel. Both computers can tell the difference between high and low-order data lines. Serial transmission. Bits are sent one after the other in a queue in serial transmission. Only one communication channel is required for serial transmission. Serial transmission can be either asynchronous or synchronous. Asynchronous serial transmission, it's called that since timing isn't important. Data bits have a distinct pattern that aids the receiver in identifying the start and end of data bits. Every data byte, for example, is prefixed with a 0, and one or more ones are added at the end. Two continuous data frames, bytes, may have a gap between them. 2. Synchronous serial transmission. As there is no method to detect start and finish data bits in synchronous transmission, timing is critical. There is no prefix/suffix technique or pattern. Several bytes can be contained in a single burst of data bits. As a result, timing becomes extremely essential. The receiver is responsible for recognizing and separating bits into bytes. The synchronous transmission offers the advantage of high speed and does not have the overhead of extra header and footer bits that asynchronous transmission has. Analog transmission. Analog transmission is a way of transmitting data using a continuous signal whose amplitude, phase, or other attribute fluctuates in proportion to the data. It could be the transmission of an analog source signal using an analog modulation method such as frequency modulation, FM, or amplitude modulation, AM, or it could be the transmission of an analog source signal with no modulation at all. It is necessary to transform digital data into an analog signal before sending it over an analog transmission. In terms of data formatting, there are two possibilities. Bandpass, frequencies of interest are filtered and pass through the filters. A bandpass filter allows a range of frequencies to pass through it. Low pass is a filter that allows low-frequency signals to pass through. Digital to analog conversion. Data is transformed into analog signals before being transferred from one computer to another through an analog carrier. To reflect digital data, analog signals are transformed. An analog signal is characterized by its amplitude, frequency, and phase. There are 4 kinds of digital-to-analog conversions. Amplitude shift keying. The amplitude of the analog carrier signal is modified to fit binary data in this conversion technique. The amplitude is kept when binary data indicates digit 1, but it is set to 0 otherwise. The original carrier signal's frequency and phase remain unchanged. Frequency shift keying. The frequency of the analog carrier signal is modified to reflect binary data in this conversion technique. This technique uses 2 frequencies, F1 and F2. One of them, for example, F1, is chosen to represent binary digit 1 and the other one is used to represent the binary digit 0. Both amplitude and phase of the carrier wave are kept intact. Phase shift keying. The phase of the original carrier signal is changed to reflect the binary data in this conversion process. The phase of the signal changes as it encounters a new binary symbol. The original carrier signal's amplitude and frequency remain unchanged. Quadrature phase shift keying. The phase of QPSK is changed to reflect 2 binary digits at the same time. This is accomplished in 2 stages. The primary binary data stream is split into 2 equal substreams. In both substreams, serial data is changed to parallel, and then each stream is converted to a digital signal using the NRZ approach. After then, the 2 digital signals are combined. Analog-to-analog conversion. To represent analog data, analog signals are transformed. Analog modulation is another name for this process. When using bandpass, analog modulation is required. Analog-to-analog conversion can be done in 3 ways. Amplitude modulation. The carrier signal's amplitude is modified to reflect the analog data in this modulation. A multiplier is used to implement amplitude modulation. The modulating signal's amplitude, analog data, is multiplied by the carrier frequency's amplitude, which then reflects analog data. The carrier signal's frequency and phase remain unaltered. Frequency modulation. The carrier signal's frequency is changed to reflect changes in the modulating signal's voltage levels in this modulation technique, analog data. The amplitude and phase of the carrier signal are not altered. Phase modulation. The phase of the carrier signal is modulated to reflect the change in the voltage, amplitude, of the analog data signal in the modulation technique. Although phase modulation is similar to frequency modulation, the carrier signal's frequency is not increased in phase modulation. To reflect voltage changes in the amplitude of the modulating signal, the carrier signal's frequency is modified, made dense and sparse. Summary of Study Session 3. In Study Session 3, please note the following. 1. Data might be analogs, such as human speech, or digital, such as a disk file. Digital and analog signals can be used to represent both analog and digital data. 2. Analog signals are in the continuous waveform in nature and are represented by continuous electromagnetic waves. 3. Digital to analog conversion is the process of converting digital data into a bandpass analog signal. Analog to analog conversion is the process of converting a low-pass analog signal into a bandpass analog signal. 4. Analog to analog conversion can be done in amplitude modulation, frequency modulation, and phase modulation. 5. Serial transmission can be either asynchronous or synchronous. Study Session 4. Transmission Media. Introduction. In data communication terminology, a transmission medium is a physical path between the transmitter and the receiver. This means it is the channel through which data is sent from one place to another. What is transmission? A transmission medium is a physical path between the transmitter and the receiver in data communication terms, i.e., the channel over which data is conveyed from one location to another. Transmission media is broadly classified into the following types. 1. Guided media. It is also known as bounded or wired transmission media. Through the use of physical linkages, signals are directed and limited in a narrow channel. Features: high speed, secure, used for comparatively shorter distances. The following are the major types of guided media. Twisted pair cable. It is made up of 2 independent insulated conductor wires that are coiled around each other. Several of these pairs are usually bundled together in a protective sheath. They are the most commonly used mode of transmission. Twisted pair is of 2 types. Unshielded twisted pair, UTP. UTP is made up of 2 insulated copper wires twisted together. This sort of cable can block interference without relying on a physical shield to do so. It's applied for telephonic operations. Shielded twisted pair, STP, to block external interference. This type of cable has a specific jacket, a copper braid cover or a foil shield. This is applied in high-speed Ethernet and telephone lines data and voice channels. Coaxial cable. It has an outer plastic covering containing an insulation layer made of PVC or Teflon and two parallel conductors each having a separate insulated protection cover. The coaxial cable transmits information in two modes: baseband mode, dedicated cable bandwidth, and broadband mode. Cable bandwidth is split into separate ranges. Cable TVs and analog television networks widely use coaxial cables. Optical fiber cable. It uses the concept of reflection of light through a core made up of glass or plastic. The core is surrounded by a less dense glass or plastic covering called cladding. It is used for the transmission of large volumes of data. The cable can be unidirectional or bidirectional. The WDM, wavelength division multiplexer, supports two modes, namely unidirectional and bidirectional modes. 2. Unguided media. Wireless or unbounded transmission media are other names for unguided media. Electromagnetic signals can be transmitted without the use of any physical medium. Features are: 1. The signal is broadcasted through air. 2. Less secure. 3. Used for larger distances. There are three types of signals transmitted through unguided media. I. Radio waves. These are simple to make and can penetrate through walls. It is not necessary to align the transmission and receiving antennas. Radio waves are used to transmit information through AM and FM radios, as well as cordless phones. 2. Microwaves. It's a line-of-sight transmission, which means the sending and receiving antennas must be perfectly aligned. The height of the antenna is directly proportionate to the distance reached by the transmission. Mobile phone communication and television distribution are two of the most common uses for microwaves. 3. Infrared. Infrared waves are utilized for communication across short distances. They are unable to pass through barriers. Interference between systems is avoided as a result of this. Infrared is used in TV remotes, wireless mouse, keyboards, printers, etc. 4. Light waves. Light or optical signaling is the highest electromagnetic spectrum that can be employed for data transmission. Laser is used to accomplish this. Because of the frequency light uses, it tends to travel strictly in a straight line. Hence the sender and receiver must be in line of sight. Because laser transmission is unidirectional, at both ends of communication the laser and the photodetector need to be installed. Multiplexing. Multiplexing is a technique for processing many analog and digital transmission streams at the same time across a shared link. Multiplexing separates a high-capacity channel into logical mediums of lower capacity, which are subsequently shared by many streams. The process of combining the data streams is known as multiplexing and the hardware used for multiplexing is known as a multiplexer. Multiplexing is achieved by using a device called multiplexer, MUX, that combines n input lines to generate a single output line. Multiplexing follows many to one, i.e., n input lines and one output line. Demultiplexing is achieved by using a device called demultiplexer, DeMux, available at the receiving end. DeMux separates a signal into its component signals, one input and n outputs. Therefore, we can say that demultiplexing follows the one-to-many approach. Multiplexing techniques. Multiplexing techniques can be classified as frequency division multiplexing, FDM. Frequency division multiplexing is a technique in which the available bandwidth of a single transmission medium is subdivided into several channels. Small black square. It is an analog technique. Small black square. The input signals are translated into frequency bands by using modulation techniques, and they are combined by a multiplexer to form a composite signal. Small black square. The main aim of the FDM is to subdivide the available bandwidth into different frequency channels and allocate them to different devices. Small black square. Using the modulation technique, the input signals are transmitted into frequency bands and then combined to form a composite signal. Small black square. The carriers which are used for modulating the signals are known as subcarriers. Wavelength division multiplexing, WDM. Wavelength division multiplexing is the same as FDM except that the optical signals are transmitted through the fiber optic cable. WDM is used on fiber optics to increase the capacity of a single fiber. It is used to utilize the high data rate capability of fiber optic cable. It is an analog multiplexing technique. Optical signals from the different sources are combined to form a wider band of light with the help of a multiplexer. At the receiving end, the demultiplexer separates the signals to transmit them to their respective destinations. Time division multiplexing, TDM. In the time division multiplexing technique, the total time available in the channel is distributed among different users. Therefore, each user is allocated a different time interval known as a time slot at which data is to be transmitted by the sender. It is a digital technique. In frequency division multiplexing technique, all signals operate at the same time with different frequencies, but in the case of the time division multiplexing technique, all signals operate at the same frequency at different times. A user takes control of the channel for a fixed amount of time. In the time division multiplexing technique, data is not transmitted simultaneously, rather the data is transmitted one by one. In TDM, the signal is transmitted in the form of frames. Frames contain a cycle of time slots in which each frame contains one or more slots dedicated to each user. There are two types of TDM. 1. Synchronous TDM. 2. Asynchronous TDM. Synchronous TDM. A synchronous TDM is a technique in which a time slot is pre-assigned to every device. In synchronous TDM, each device is given some time slot irrespective of the fact that the device contains the data or not. If the device does not have any data, then the slot will remain empty. In synchronous TDM, signals are sent in the form of frames. Time slots are organized in the form of frames. If a device does not have data for a particular time slot, then the empty slot will be transmitted. The most popular synchronous TDM are T1 multiplexing, ISDN multiplexing, and sonnet multiplexing. Asynchronous TDM. An asynchronous TDM is also known as statistical TDM. An asynchronous TDM is a technique in which time slots are not fixed as in the case of synchronous TDM. Time slots are allocated to only those devices which have the data to send. Therefore, we can say that asynchronous time division multiplexer transmits only the data from active workstations. An asynchronous TDM technique dynamically allocates the time slots to the devices. In asynchronous TDM, the total speed of the input lines can be greater than the capacity of the channel. Asynchronous time division multiplexer accepts the incoming data streams and creates a frame that contains only data with no empty slots. Switching. Switching is the process of forwarding packets from one port to another that leads to the destination. When data enters a port, it is referred to as ingress, and when data leaves a port, it is referred to as egress. A communication system may include several switches and nodes. At a broad level, switching can be divided into two major categories. Connectionless, the data is forwarded on behalf of forwarding tables. No previous handshaking is required and acknowledgements are optional. Connection-oriented, before switching data to be forwarded to the destination, there is a need to re-establish a circuit along the path between both endpoints. Data is then forwarded to that circuit. After the transfer is completed, circuits can be kept for future use or can be turned down immediately. Circuit switching. Circuit switching occurs when two nodes communicate with each other across a dedicated communication path. There must be a pre-specified route for data to travel from, and no additional data is allowed. For data to be transferred by circuit switching, the circuit should first be established. Circuits can be permanent or temporary. Applications that use circuit switching may have to go through three phases. 1. Establish a circuit. 2. Transfer the data. 3. Disconnect the circuit. Circuit switching was created for voice applications. Circuit switching is best demonstrated through the use of the telephone. A virtual path is established between the caller and the callee over the network before a user may make a call. Message switching. This method was a combination of circuit and packet switching. The full message is handled as a data unit in message switching and is switched/transmitted in its entirety. A message switching switch initially gets the entire message and buffers it until resources are available to send it to the next hop. If the next hop does not have enough resources to accommodate large-size messages, the message is stored and the switch waits. Packet switching. Packet switching is a method of transferring data to a network in the form of packets. To transfer the file fast and efficiently over the network and minimize the transmission latency, the data is broken into small pieces of variable length, called packet. Shortcomings of message switching gave birth to the idea of packet switching. The switching information is added in the header of each packet and transmitted independently. Summary of Study Session 4. In Study Session 4, please note the following. 1. A transmission medium is a physical path between the transmitter and the receiver in data communication terms. 2. Transmission media is broadly classified into guided media and unguided media. 3. Guided media is also known as bounded or wired transmission media. 4. The signal is broadcasted through the air, less secure, used for larger distances are the features of unguided media. 5. Laser is safe for data transmission as it is very difficult to tap a 1 mm wide laser without interrupting the communication channel. 6. To transfer the file fast and efficiently manner over the network and minimize the transmission latency, the data is broken into small pieces of variable length, called packet. Study Session 5. Data Link Layer Introduction. Introduction. The OC layered model's data link layer is the second layer. This layer is one of the most difficult to understand, with several functionalities and risks. The data connection layer hides the underlying hardware features and represents itself to the upper layer as a communication medium. Data link layer. The data link layer is the fourth layer from the top and the second layer from the bottom in the OC model. This layer is one of the most difficult to understand, with several functionalities and risks. The data connection layer hides the underlying hardware features and represents itself to the upper layer as a communication medium. The communication medium that connects the nearby nodes is known as links, and each datagram needs to be transported via an individual link to get from source to destination. 1. The main responsibility of the data link layer is to transfer the datagram across an individual link. 2. The data link layer protocols are Ethernet, Token Ring, FDDI, and PPP. 3. The data link layer protocol defines the format of the packet exchanged across the nodes as well as the actions such as error detection, retransmission, flow control, and random access. Services of data link layer are 1. Framing and link access. 2. Reliable delivery. 3. Flow control. 4. Error detection. 5. Error correction. 6. Half duplex and full duplex. Error detection and correction. An error is a situation when the message received at the receiver end is not identical to the message transmitted. Many factors, such as noise, crosstalk, and others, can cause data to be corrupted during transmission. The upper layers are unaware of actual hardware data processing and work on a generalized understanding of network architecture. As a result, the upper levels anticipate error-free communication between the systems. Most of the applications would not function expectedly if they receive erroneous data. Applications such as voice and video may not be that affected, and with some errors, they may still function well. Error detection techniques. The most popular error detecting techniques are 1. Single parity check. 2. Two-dimensional parity check. 3. Checksum. 4. Cyclic redundancy check. Single parity check. Single parity checking is a simple mechanism and inexpensive to detect errors. In this technique, a redundant bit is also known as a parity bit, which is appended at the end of the data unit so that the number of ones becomes even. Therefore, the total number of transmitted bits would be 9 bits. If the number of ones bits is odd, then parity bit 1 is appended, and if the number of ones bits is even, then parity bit 0 is appended at the end of the data unit. At the receiving end, the parity bit is calculated from the received data bits and compared with the received parity bit. This technique generates the total number of ones even, so it is known as even parity checking. Two-dimensional parity check. Performance can be improved by using the two-dimensional parity check, which organizes the data in the form of a table. Parity check bits are computed for each row, which is equivalent to the single parity check. In a two-dimensional parity check, a block of bits is divided into rows, and the redundant row of bits is added to the whole block. At the receiving end, the parity bits are compared with the parity bits computed from the received data. Checksum. A checksum is an error detection technique based on the concept of redundancy. It is divided into two parts. Checksum generator. A checksum is generated at the sending side. The checksum generator separates the data into equal n-bit pieces, which are then added together using one's complement arithmetic. The sum is supplemented and attached to the original data, which is referred to as the checksum field. The network is used to transmit extended data. Checksum checker. A checksum is verified at the receiving side. The receiver separates the incoming data into n-bit segments, adds them all up, and then complements the result. The data is accepted if the complement of the sum is 0, otherwise, the data is rejected. Cyclic redundancy check, CRC. CRC is a redundancy error technique used to determine the error. Following are the steps used in CRC for error detection. In the CRC technique, a string of n zeros is appended to the data unit, and this n number is less than the number of bits in a predetermined number, known as the division, which is n plus 1 bits. Secondly, the newly extended data is divided by a divisor using a process is known as binary division. The remainder generated from this division is known as CRC remainder. Thirdly, the CRC remainder replaces the appended zeros at the end of the original data. This newly generated unit is sent to the receiver. The receiver receives the data followed by the CRC remainder. The receiver will treat this whole unit as a single unit, and it is divided by the same divisor that was used to find the CRC remainder. Error correction. Error correction codes are used to detect and correct errors when data is transmitted from the sender to the receiver. Error correction can be handled in two ways. Backward error correction. Once the error is discovered, the receiver requests the sender to retransmit the entire data unit. Forward error correction. In this case, the receiver uses the error correcting code which automatically corrects the errors. Data link control and protocols. The data link layer provides data link control as a service to ensure reliable data transport over the physical medium. In half-duplex transmission mode, for example, one device can only transmit data at a time. If both devices at the end of the link transmit data at the same time, they will collide, resulting in information loss. Flow control. It is a set of procedures that tells the sender how much data it can transmit before the data overwhelms the receiver. The receiving device has limited speed and limited memory to store the data. Therefore, the receiving device must be able to inform the sending device to stop the transmission temporarily before the limits are reached. It requires a buffer, a block of memory for storing the information until it is processed. Two methods have been developed to control the flow of data. A. Stop and wait. In the stop and wait method, the sender waits for an acknowledgement after every frame it sends. When an acknowledgement is received, then only the next frame is sent. The process of alternately sending and waiting for a frame continues until the sender transmits the end of transmission frame. B. Sliding window. The sliding window is a method of flow control in which a sender can transmit several frames before getting an acknowledgement. In sliding window control, multiple frames can be sent one after the other, due to which capacity of the communication channel can be utilized efficiently. Summary of Study Session 5. In Study Session 5, please note the following. 1. The data connection layer hides the underlying hardware features and represents itself to the upper layer as a communication medium. The communication medium that connects the nearby nodes is known as links, and each datagram needs to be transported via an individual link to get from source to destination. 2. An error is a situation when the message received at the receiver end is not identical to the message transmitted. Many factors, such as noise, crosstalk, and others, can cause data to be corrupted during transmission. 3. In a single parity check, a redundant bit is also known as a parity bit, which is appended at the end of the data unit so that the number of ones becomes even. Therefore, the total number of transmitted bits would be 9 bits. 4. Flow control is a set of procedures that tells the sender how much data it can transmit before the data overwhelms the receiver. The receiving device has limited speed and limited memory to store the data. 5. Sliding window ARQ is a technique used for continuous transmission error control. Study Session 6. Network Layer Introduction. Introduction. The network layer is the third layer in the OC model. The network layer controls host and network addressing, subnetwork management, and internetworking. The network layer is in charge of routing packets from a source to a destination within or outside of a subnet. What is network layer? The network layer is the third layer of the OC model. It handles the service requests from the transport layer and further forwards the service request to the data link layer. The network layer translates the logical addresses into physical addresses. It determines the route from the source to the destination and also manages the traffic problems such as switching, routing, and controls the congestion of data packets. The main role of the network layer is to move the packets from sending host to the receiving host. The main functions performed by the network layer are: 1. Routing. 2. Logical addressing. 3. Internetworking. 4. Fragmentation. Network addressing. The Internet Protocol is a well and extensively used network layer protocol that allows end-to-end devices to communicate across the Internet. One of the most important functions of the network layer is Layer 3 network addressing. Network addresses are always logical, meaning they are software addresses that can be modified with the right configurations. IP addressing is a method of distinguishing between hosts and networks. A host is always assigned to a specific network since IP addresses are assigned hierarchically. The host that needs to communicate outside of its subnet must know the destination network address to which the packets or data will be delivered. Network routing. A router is a process of selecting a path along which the data can be transferred from the source to the destination. Routing is performed by a special device known as a router. In the OC paradigm, a router operates at the network layer, while in the TCP/IP model, it operates at the Internet layer. A router is a networking device that forwards packets using information from the packet header and forwarding table. Routing metrics and costs. The best route to the destination is determined using routing metrics and costs. These parameters are known as metrics, and they are employed by protocols to calculate the shortest path. The most common metric values are 1. Hop count, 2. Delay, 3. Bandwidth, 4. Load, 5. Reliability. Types of routing. Routing can be classified into 3 categories: static routing, default routing, and dynamic routing. Static routing. 1. It is a technique in which the administrator manually adds the routes in a routing table. 2. In this technique, routing decisions are not made based on the condition or topology of the networks. 3. A router can send the packets for the destination along the route defined by the administrator. 4. Static routing is also known as non-adaptive routing. Default routing. Default routing is a technique in which a router is configured to send all the packets to the same hop device, and it doesn't matter whether it belongs to a particular network or not. A packet is transmitted to the device for which it is configured in default routing. Default routing is used when networks deal with a single exit point. It is also useful when the bulk of transmission networks have to transmit the data to the same HP device. When a specific route is mentioned in the routing table, the router will choose the specific route rather than the default route. The default route is chosen only when a specific route is not mentioned in the routing table. Dynamic routing. In dynamic routing, RIP and OSPF are the protocols used to discover the new routes. It is also known as adaptive routing. Dynamic protocols are used to discover new routes to reach the destination. If any route goes down, then the automatic adjustment will be made to reach the destination. It is a technique in which a router adds a new route in the routing table for each packet in response to the changes in the condition or topology of the network. Summary of Study Session 6. In Study Session 6, please note the following. 1. The network layer is the third layer of the OC model. It handles the service requests from the transport layer and further forwards the service request to the data link layer. 2. Quality of service management, load balancing, and link management, security, interrelation of different protocols and subnets with different schema, different logical network designs over the physical network design, L3 VPN, and tunnels can be used to provide end-to-end dedicated connectivity are all features of the network layer. 3. One of the most important functions of the network layer is Layer 3 network addressing. Network addresses are always logical, meaning they are software addresses that can be modified with the right configurations. 4. Routing is performed by a special device known as a router. In the OC paradigm, a router operates at the network layer, while in the TCP/IP model, it operates at the Internet layer. 5. The MAC address inscribed on the NIC identifies each device on the network. As a result, we can conclude that devices require the MAC address to communicate over a local area network. It is simple to modify the MAC address. Study Session 7. Transport Layer Introduction. Introduction. The transport layer is the next in the OC model, Layer 4. This layer contains all modules and operations related to the conveyance of data or data streams. This layer, like all others, connects with the remote host transport layer. The transport layer allows two processes on remote systems to link peer-to-peer and end-to-end. The transport layer receives data from the higher layer, the application layer, breaks it down into smaller pieces, numbers each byte, and passes it to the bottom layer, the network layer, for delivery. Transport layer. The fourth layer from the top is the transport layer. The transport layer's primary function is to provide direct communication services to application processes running on various hosts. The transport layer allows application processes running on separate hosts to communicate logically. Services provided by the transport layer. The transport layer provides services that are similar to those provided by the data link layer. The data link layer provides services within a single network, whereas the transport layer provides services across many networks on the Internet. The physical layer is controlled by the data link layer, whereas the lower layers are controlled by the transport layer. The services provided by the transport layer protocols can be divided into 5 categories. 1. End-to-end delivery. 2. Addressing. 3. Reliable delivery. 4. Flow control. 5. Multiplexing. Transport layer protocols. The transport layer is represented by 2 protocols, TCP and UDP. The IP protocol in the network layer delivers a datagram from a source host to the destination host. Today's operating systems offer multi-user and multi-processing environments, an executing program called a process. When a host delivers a message to another host, the sourcing process is sending a process to the destination process. The transport layer protocols define some connections to individual ports known as protocol ports. A. UDP1. UDP stands for User Datagram Protocol. 2. UDP is a simple protocol and it provides non-sequence transport functionality. 3. UDP is a connectionless protocol. 4. This type of protocol is used when reliability and security are less important than speed and size. 5. UDP is an end-to-end transport-level protocol that adds transport-level addresses, checksum error control, and length information to the data from the upper layer. Protocol ports are defined as the transport layer protocols that define some connections to individual ports. B. TCP. 1. TCP stands for Transmission Control Protocol. 2. It provides full transport layer services to applications. 3. It is a connection-oriented protocol, which means the connection is established between both the ends of the transmission. For creating the connection, TCP generates a virtual circuit between sender and receiver for the duration of a transmission. Features of TCP protocol. The following are the features of the TCP protocol. 1. Stream data transfer. 2. Reliability. 3. Flow control. 4. Multiplexing. 5. Logical connections. 6. Full duplex. Summary of Study Session 7. In Study Session 7, please note the following. 1. The fourth layer from the top is the transport layer. The transport layer allows application processes running on separate hosts to communicate logically. 2. End-to-end delivery, addressing, reliable delivery, flow control, and multiplexing are services provided by transport layer. 3. Error control, sequence control, loss control, and duplication control are aspects of reliability. 4. Flow control is used to keep the sender from sending too much data to the receiver. When a receiver is overloaded with data, it discards packets and requests that they are retransmitted. 5. Multiplexing is the technique of taking data from several programs and passing it to other applications on computers. The data is forwarded to the correct application at the receiving end.